Good afternoon, participants. Thank you all for joining in person, and many of them are joining virtually. We have a special event today because we have a special speaker. She's our alumni, she's our professor. Her name is Natalia. She is a senior manager of Operations Research Center of Excellence working at SAS. She is leading a team of Advanced Analytics Research and Development that designs, develops, and implements machine learning and operational research applications in healthcare, manufacturing, and retail. It is my honor to welcome you to the stage. The topic for today is data analytics for good. Thank you.
Thank you so much. Thank you, guys. I'm gonna go move around here. Well, thank you everyone for being here Friday afternoon. We're almost ready for the weekend, so I appreciate the time spending with me. I was asked to kind of make a presentation to you on kind of current work or what is meaningful that might be represented to you guys as well. So I chose the topic of data analytics for social good, which has been very, very deep to my heart for quite a while, actually. So I'm going to tell you just a few minutes about myself a little bit and kind of the trajectory that I followed to get where I am. I do lose air very quickly with the mask, so be patient with me if I have to kind of take a little bit of a breath. So I was born in Russia. That's where the accent is coming from. It doesn't go away no matter what I do. It's just there. However, I grew up in Mexico, so I'm actually passionate. I'm Mexican. I lived there more than 20 years, and I went to school there. I just started my PhD program there, and then I moved here to NC State, and I finished the PhD in operations research here at State, and then I started working at SAS. How many of you guys? Yes, please. Oh, you do want me to? Okay. Is that because of the microphone?
Oh, the camera.
Oh, the camera. Oh, I'm sorry. Okay, sure. Is that good?
Can you squeeze in?
Can I squeeze it? Where?
Perfect.
Okay. Oh, I see. Oh, I see. You want me to be here. Okay. Okay. So it's better if I get there, I guess, in the back. Okay. Sure. No worries. Okay. Okay. Okay, cool. Thank you. Okay, so how many of you guys are graduate students? Are most of you grads? Any undergrads here? Okay, cool. I'm just curious too. So when I was an undergrad, kind of halfway through my program as industrial engineer, I did decide that I want to work for academia, mostly because I loved teaching. So it's kind of like, okay, well, I'm going to go for a master's, and then I'm going to do a PhD program. I actually did not have an option back in Mexico of going straight to PhD, which is a wonderful option that you have here. I didn't, so I have to go through master's and then PhD program. When I came here to PhD program, how many of you are master students? Most of you, how many are PhD students? Cool. Okay, so halfway through the program, I'm out of funding. Okay, so probably many of you are kind of familiar with the concept, but I did have Dean Scholarship for my first year, then I had a TA assistantship for my second year, and then I kind of had to find ways to fund. And there was this opportunity at SAS, full-time opportunity, and I decided to take it, and it was temporary. So in my head, it was, well, that's kind of a way to make money while I am finishing the PhD. So I started working full-time at SAS while finishing my PhD. Big mistake, don't do that. I feel like I missed out a lot. Internships have, like, part-time work is amazing while you are studying. Full-time is a no-no. So obviously my PhD kind of took longer. The good thing that came out is that even though originally my idea was that I'm just finishing my PhD and then I started applying for academic jobs, I actually really loved applied work. So I really loved the work that I was doing at SAS. I first started building time series for retail industries. And then once I finished PhD, I moved into an optimization team where we were building optimization applications for our customers. And I really liked the applied work. So I decided to stay in industry. So for me, that was kind of last minute change in my path. At the same time, I mean, a couple years, well, 5 years ago, I started looking for opportunities to teach at least like one class a year or something like that, because I'm very passionate about teaching. And I started teaching at NC State. I started teaching data analytics here about 5 years ago. And now I kind of manage, depending on the semester. I also teach optimization at Duke and machine learning applications at MIT, just kind of depending on the semester, trying to kind of juggle with my job. But so that's kind of my story. I'm very happy where I am, particularly because my job allows me to work on applied work. That's partially what I'm going to be talking today, like seeing actual customers. Like we work with Procter & Gamble, we work with Cleveland Clinic, we work with these kind of big organizations as well as small organizations to help them with their processes, building analytical software for them using optimization and machine learning. But my job also, my company allows me that flexibility, which is key for me to keep myself happy in terms of, and okay, well, I also want to teach, but I'm also very passionate about using technology for social good. And so that's where I'm kind of coming to the conversation that we're going to have today, which is after kind of many years of applying technology, operations research, machine learning to these really big organizations, which is super fun. Usually those models are super complicated. You have to do a lot of tuning to get like the good performance out of them. It's super fun. But kind of through the years, I started feeling like, okay, well, can we do something that feels a little bit good, like in my heart, that is kind of a bit more meaningful for the world or for someone in particular, but a little bit less related to kind of financial benefits of a multinational and more related to life quality and so on. So I started kind of exploring applications, exploring where could I start contributing. And I've had multiple opportunities since. I started my first kind of, my first experience was with an organization that's called DataKind, and they did like one of these super big weekend data dive. Basically, we started like on a Friday and we were done on Sunday to help nonprofit organizations through data, almost like a hackathon, but helping nonprofits. And I love that. That just felt so good. And ever since, I kind of started finding these opportunities to participate in projects that support particularly nonprofit organizations. Most of my projects have been with my students during my classes. I find basically I just approach the nonprofits, like the local nonprofits that are here, like Wake County Animal Center, approach them saying, hey, I'm looking potentially for questions that maybe I can help you with in terms of data. Do you have some data that I can help you process? Do you have some data that you need some answers from for decision making? Just kind of very basic questions for them. These nonprofits rarely have data scientists. Wake County Animal Shelter, we don't have a data scientist, but they do have data that could benefit if someone could derive some meaningful insights and help them on making better decisions to support more animals, right? And that is just one example of many, many of these nonprofit organizations that do not have the financial means to hire a team of data scientists, but still could benefit, okay? And that's where we come in. So what I'm going to do is I'm going to talk to you about 4 particular projects that I thought were very cool. These 4 projects, all of them we have implemented, and they are optimization projects. I have to tell you that it's actually rare to find a true optimization project for a nonprofit, in particular a small nonprofit, because they are in earlier stages of the data analytics development, right? Many times, all they need sometimes is some data processing or even some visualizations, kind of historical analysis can be super helpful for them. So it's not as common to kind of start with optimization, which is kind of the final piece of advanced analytics. But today, for since you're grad students and you're probably interested in technology as well, I'm going to talk to you about 4 projects that are operations research projects. Okay, so these are the projects I want to talk to you about. WakeMed Mother's Milk Bank, one of my favorites, Durham Public Schools, Cleveland Clinic, and Boston Public Schools. I'm going to give you, basically, since it's 4 projects in a short amount of time, I'm going to give you an overview. If any of you are interested in a specific project, feel free to shoot me a note, shoot me an email, and I'll be very happy to either point you to a blog or some publications that we've done on that particular project if you're interested in more details. Okay, breathe. Okay, it's really hard, guys. I don't know if you've tried this, but like talking like that with a mask. Okay, good. I'm good. Okay. Can I make it smaller so it doesn't bother me? There. WakeMed Mother's Milk Bank. This is an organization that collects donated breast milk for babies, particularly babies in NICUs. So as you're probably aware, those are the premature babies, what they need the most besides medical care in terms of nutrition is breast milk. There's nothing better. So this organization helps families that for whatever reason, the mothers are not able to provide breast milk to their babies. They do a collection, and there's this, like, as you can imagine, it's a big logistics problem, but they collect it and then they distribute, okay? This organization has about 26 milk banks. And last year they had 330 new donors. It's local, but it distributes to North Carolina, South Carolina, and sometimes even outside of those 2 states. And last year they had 400,000 NICU feeds for babies. So that's a lot. This is not the number of babies. This is a number of feeds. So every time it's like a measure of how much you give to a premature baby. So that is very significant. I am very, very, very passionate about this organization in particular because I was one of the beneficiaries. That is my little baby. I had no idea that kind of lack of breast milk was a problem, as I'm sure you guys have no clue what I'm talking about when I'm saying that that can be a problem. You guys are very young, but it can be, and it's devastating. So my family, we went through big pain and so on. And then I was at WakeMed Cary, and they offered donor breast milk to my baby, and that was a big difference for her. And then I'm just kind of imagining all these women, who have their own babies, or sometimes it's different conditions, and then they donated for my baby to be better. So I'm very passionate about them. By the way, I'm happy to share the slides. The slides do have links. These are publications that I've done, kind of a little bit about my story. My baby's 3.5 now, and she's super opinionated and super independent. So she's doing good. Okay, this project was developed with a group of students here from NC State. This was, I think, 2-3 years ago. Our main contact at Mother's Milk Bank, WakeMed, was Montana Wagner. She's actually a grad student from NC State Nursery School, I think, as well. So those are the students, the awesome students that work with me in this project. Okay, so high-level problem description is you see the map, you see the little areas there, those are zip codes. And that is where the color means where are the most amount of donors are located, okay? The thing is, Milk Bank pays for shipping. So for example, if I have a mom that is far, almost like in Tennessee, and she's not gonna drive here, right? And she's not gonna pay for shipping for this like super specialized containers, and because it has to be cold and so on. So what Mother's Milk does is it ships boxes to these women, then they place the breast milk there, and then they ship back. So that is expensive. Average shipping distance, so average how much they shipped last year, no, actually it's across the years, it's about 11,000 miles, and the shipping cost us $40,000, which for this organization is actually a lot. So every year they have to pay a lot of money for the transportation of that breast milk. So what we are trying to what we help them with is how to potentially reduce those costs. So what they said is they might be able to open drop-off locations. So Cary Wake Med is actually a drop-off location. So if a mom lives in Cary, she actually is probably willing to drive 10 minutes, drop off and then leave. But if you are far away in Tennessee, you're not going to drive. So what about them setting up some other drop-off locations, okay? And probably all of you are like, oh, facility location, right? Like Activate. This is a facility location problem. And in this case, I mean, they actually have a lot of good relationships with other hospitals. So it's fairly easy for them to place these drop-off locations at like other hospitals. And then the hospitals, they drive to get that breast milk. So they don't have to ship it anymore. What they're trying to do, they're trying to minimize the shipping costs. So that's our objective function and our optimization formulation. And the constraints is we're assuming that wherever we place it, the donor will travel at most 12 miles. If you don't have a drop-off location within 12 miles, you're going to be shipped. So we'll still have to pay for shipment. And they kind of said that based on their calculations, they are able to open at most 15 drop-off locations. Tiny baby problem, 6,000 variables, 363 constraints. It's not a problem at all. We solved it, students solved it with SAS, super quick, all good. And expected savings were about 22,000 per year. So that's a lot. So we're talking about more than 50% of their costs, okay? Now, many times, and I hope I'm not kind of being a bummer here for you guys, but when we build automated implementations, we're using data analytics, optimization, so on, for a solution, many times they're not being implemented exactly the way data analytics is recommending, okay? There's some processing, there's some adjustments. So in this case, they didn't open exactly where the 15 locations, but they did open 6 locations due to this analysis. So they were able to present to their executives the analysis that the students did. And because of that, they opened 6 new locations and they also had cost savings. So that is the kind of simplest problem, I guess, that we're gonna cover today. And so what I'm gonna do is, just because of time, let me move forward. Okay, I'm gonna cover the 4 projects. And then depending on how much time we have, I'll be very happy to answer questions. Sounds good? Okay, cool. So as I mentioned, I can send these slides to you guys, and you guys can, can share, because there has been publishing blogs and things on this case study, so you can get more information. Okay. Awesome. Next one, Durham Public Schools. Okay. Durham Public Schools has about 53 schools, 32,000 students, and operates a budget of $460 million. At least last year was $460 million. Okay. The team that worked in this was a SAS team. So this was my team. Most of this were my team that works with me in R&D. Matt Fletcher, actually, I should put an NC State logo, because he was our intern. He was a PhD student here at SAS, here at NC State last summer, and he was our intern. So he kind of began the project working with us, and then he transitioned to other members in my team. And we worked mostly with executive directors for the planning in Durham Public Schools. Okay, COVID, okay. So we're talking about September 2020. Okay, so everything was already closed, and still that semester, they kind of, I don't know if you guys remember, they kind of attempted, but still like pretty much that fall, August semester, most of the things were still closed, at least in the schools, okay? In September, they started analyzing, okay, what can we do to allow for some face-to-face in spring, so January 2021, so January this year. Mostly we're talking here about elementary schools. So again, you guys are young, you don't know this, but having like a 6-7-year-old trying to take a meeting on like a class on Zoom means you're not working. because that means that you kind of have to be with them. It's incredibly hard. So they were trying to understand, okay, what is the arrangement that we can do to get the maximum amount of time for the elementary school kids, at least for the youngest ones, high school, I mean, they can handle it, but the little ones, to get them face-to-face while respecting all the distance requirements, okay? A little bit of a plot here to understand that, of course, if they just use the capacity that using the capacity that they have, there is no way that they could allow that distancing. At that point, this was Orange County, it gave them instruction that you have to use only 50% of your capacity. That was the direction. So they kind of didn't do like this 6-feet calculation, but they said, okay, let's just do 50% capacity, okay? So at 50% capacity, you're pretty much getting 50% of the students in, right? So how do you manage? So the idea was to find alternate schedules, okay? And this is not like crazy innovative. Pretty much all the schools around the world started thinking on how to make this work, how to have a group of students, half of a group of students come in 8 to 10, and another group come in 11 to 1, or half of a group to come in on Mondays and Wednesdays and another Tuesdays and Thursdays. As you can imagine, there's a lot of different permutations there while we're trying to maximize the face-to-face time. So that calls for an optimization problem. So what we're trying to do is assign that students to times given like available rooms, maximizing face-to-face time, limited to physical space capacity and social distancing. Still baby problem, talking now, this is, we have 700 binary variables. We have 1,300 continuous variables and 2,000 linear constraints. Solving time a little bit longer. This is a scheduling problem, okay? Anyone who's familiar, scheduling problem, they have a certain mathematical structure that's actually harder to solve than a facility location problem by default. But still, for us, this is a baby problem. We solved that. In addition, something that was helpful for them was we built dashboards. So that is very important. I mean, my favorite part is actually mathematical formulation and coding. I love coding. It's like meditating for me, honestly. Like I forget everything when I'm coding and debugging and everything. However, it is very important that whenever we have results, we find a way to present them. Okay, and I cannot understate that enough. Presentation is super important. So we worked really closely with Durham Public Schools to create a user interface for them, okay? Because they are not able to run the code, and they wanted to analyze the different kind of what-if scenarios in terms of those configurations. So we built some user interfaces for them to try to understand. Kind of here, they were able to input different parameters, and then they were able to see, okay, what is the kind of the best allocation. Lots of work done. And then in like late December, they decided to keep virtual for the next semester. So that was just the thing, that was just the reality of last semester, but we know that that was useful for them actually for next year. But then that time, everyone was kind of disappointed, but it is what it is. Okay, so that was my Durham Public Schools. We have, actually, this is the project that if you're interested, it has the most details in terms of formulations. One of the blogs, so this is a high-level blog that I wrote, and this is a blog that has all the mathematical formulation in the code, and this has a video. I actually walked through that user interface, so there's a lot of detailed information here. Okay, breathe. Thank you. You guys are patient. Okay, Cleveland Clinic. So one more on COVID, okay? Cleveland Clinic is a massive organization. They're like one of the largest chain of health facilities across the nation. They have 2+ million patients this year, each year, about 10 billion operating revenue. They have 26 locations, most of them in Ohio, but not all of them. They actually have a location in Florida as well. they have a super strong data analytics program, actually. Data analytics group, sorry. They have, their data scientists are amazing, and they have done a lot of very, very cool things across the years. And in 2021, they won this award, which is very relevant for analytics for their initiatives. This initiative I'm going to talk to you guys is part of what they submitted. It's not the only one, but they submitted all the analytics initiatives that they had. This was one of them, and they won the award in 2021. Okay, this was the Cleveland Clinic team. So this is, we work at SAS, and those are some of this awesome data scientists from Cleveland Clinic. Okay. So COVID, we're talking about April 2021, okay? So what happens for the hospitals is everything closes but ICUs and ventilators and everything for COVID patients. Unless there's like the emergency department still working, but everything that is, forgot the word optional, everything that is not emergency was postponed. Okay, so if you were having a cornea surgery or a spine surgery that was not dead alive type of situation, then it was postponed because they wanted to focus, and that happened across for most of the hospitals across the nation. So what they wanted to understand is how can they start offering services to those patients while making sure that they have the capacity to deal with the emergencies and with the ICUs and ventilators for COVID patients. So a part of this project that I'm not talking about is that we actually help them to build epi models to forecast the COVID patients. Since that is not a optimization project, I kind of wasn't talking about that, but that was one of the inputs into this problem. So we knew, we were estimating how many COVID patients they may have. So we focused on 4 types of resources. We focused on hospital beds, operating rooms, ICU beds, and ventilators. Another key element then, which is not a problem now, but if you guys remember April, there were like no tests, right? It was like impossible to get a COVID test anywhere. So hospitals obviously have them, but they were also very limited. They didn't want to get anyone into their facilities without testing them first. So one of the main limitations at some point was actually not only their ICU beds and ventilators, it was the availability of tests. And they had the two tests, which we now know there's a fast one, there's a long one. So they knew kind of like in April, they were going to have X amount of tests. And then they knew based on their supply chain management that in July, they will have twice that. And then August, they will have twice that. So they were trying to understand kind of like a long planning horizon, how many more patients they will be able to take in through time. So we were talking about kind of this phased approach, okay? Our problem, what we were tasked with is to generate this optimal restarting plan. They called it restarting plan, balancing hospital economics. In terms of we want to get the patients in to keep the cash flowing. This is a nonprofit, but if they have no cash flowing, they won't have any way to support even the COVID patients. Efficient use of resources, but keeping the care quality. A little bit on hierarchies. This is where you kind of will start seeing a little bit on the complexity of the mixed integer programming here. So what we call services, these are the different surgeries, for example, that they can offer, or appointments that they can offer. So cardiac services can have surgery or cath. Orthopedics can have sports or joint illnesses that they treat. One facility has, this is what we call services, and this is sub-services. So this is a hierarchy, okay? And then we have resources. So the resources are beds. The hospital beds usually are shared across the service. So while our decision variable or decisions were made at subservice level, So we were deciding, okay, are we opening the acne services? Are we opening the cat services? The beds are shared for the entire service, not the sub-service, but service. ORs are shared for the entire facility. Similar to ventilators, whatever ventilators they have in the hospital is shared across the hospital. But the COVID tests were for the entire Cleveland Clinic. So the number that they gave us was for the entire Cleveland Clinic. What does that mean, guys? That means that we have one big monster of a problem instead of little problems, right? If I had COVID tests for each one of the facility, what I will be the problem I will be solving is a small problem for each facility, right? However, since I don't have and I don't want to have a pre-allocation of the COVID tests to facilities, we have a much larger problem in here in terms of complexity. Okay, decisions, as I mentioned, which sub-services to reopen and when. Remember, I told you this is about time. So like maybe in April, we cannot open the, which was one of those, we cannot open the joint services, but then maybe in August we can. We're maximizing revenue and margin. We're talking about the cash flow, and constraints are capacity limitations and COVID-19, the test availability. Okay, larger problem, talking about 200K variables approx, binary variables, continuous variables are cheap, and then about 200K constraints. So harder problem to solve. We still actually, we did add some tools, and that is like maybe another conversation that we have. We add some kind of like a heuristic within the optimization to make it solve faster, but eventually we got it down to approximately 1 minute solve time. Okay, similar to what I described with Durham Public Schools, even though Cleveland Clinic has a fantastic data science team, they had to present these results to their executives to make a decision, not just because a software will tell them, oh, hey, you should open this on these dates. They will just go ahead and, oh, sure, okay. No, you have to do some user adoption. You have to make sure that they're convinced to actually take the decision. So we built also user interface for them where they were able to kind of go back and analyze kind of their history. And then they had a way to input parameters to say, for example, okay, if I want to use my ICU capacity at most 50%, let's rerun optimization and see how would my plan of reopening change. If I now have many more COVID tests in August, how will that change my optimization? So they wanted a tool they can interact with, and that happens pretty much in most of my engagements. So we build this tool with them, and they are using it even post-COVID. Once they kind of fully reopen, they're still using it for post-COVID to kind of try to understand how to better use their resources. So one of the things that I absolutely loved with this project is usually the customers I work with on kind of like a billable capacity, like we sell them software and so on, they will not allow me to post formulations or code or publish out of it, okay, because it's competitive information. We're working with Procter & Gamble to try to decide composition of detergents. They're not going to let us, it's a fantastic optimization model. They're not going to let us post it ever, right, because it's competitive. So one of the things with Cleveland Clinic, even though this was a very large engagement, since they have a very good, they're kind of very proud of themselves that they have such a good data science team. They actually wanted to help their, they wanted to help the smaller clinics to be able to take advantage of what we built for them. So they allowed us to make it all public. This project, everything is in GitHub. The formulation, the documentation, the most detailed information you need, including all the code, all this, because the code is not one piece of code, it's the whole structure, right? It's everything is in GitHub. So I was very, very happy. We're rarely allowed to do that. And Cleveland Clinic allowed us to publish everything and put it out in GitHub. So that was wonderful. There's also a video there, an overview that you guys could. I think it will, if this is a SaaS webinar. So if you're more interested, I think you can go into there and just put your name. It won't commit you to anything, but then it will allow you to watch the webinar if you wanted more information about that. And the GitHub is there. Okay, last one, breathe. Okay, Boston Public Schools. So we actually been working with these guys for several years now. And they are a very large organization that typically engages with universities around, like they work with MIT very closely too, to help them with their particular transportation issues, actually, because in Boston, the Boston Public Schools, you can leave across the town and decide to go to a school across town that's not in your neighborhood, that's not assigned to you, and the school has to send transportation for you. So that's why their transportation logistics is really, really hard. Now we worked with so about 125 schools, 50K students, and $1 billion budget last year. This is the team. This is a smaller team from SAS, and Angela and Emmanuel are the ones we work most closely with. Keep working, actually. I mean, I think it's going to be 2.5 years now that we keep working on this problem. Okay, so that's a bus picking up students and then dropping up students at schools. Okay, so as you can see, it also doesn't go from different houses to just one school, like here, for example. Like the buses will pick up students and go to one school, and then go pick up our students, go to another school. No, it can pick up students and go, so which is a little bit more efficient for the bus. Our problem is actually focused on what they call monitors. Students with special needs may require a person that rides with them in the bus to help them in whatever situation. There's different types of monitors. Some of them may need to be assigned one-on-one to a person, and some of them can be assigned to up to 5 students. Okay, they have in total about 3,500 routes, which is a lot, 600 buses, and then about 300 students need monitors. So we're talking about routes that have all students, but some of them need these monitors. So our project is about assigning those monitors to the routes. Okay, to find out, to make sure that we have a full coverage of the students. Usually how they work, they actually for years have been working on this manually, which is this is a crazy complicated problem. They will actually go in Excel and they will like close themselves in for a week and like with little post-its on the walls and try to create this, what they call packages. A package is a set of routes that one monitor can have. Okay, so they will have basically, and what they're trying to do is put as many routes as possible for a monitor, because if a monitor has more than X amount of hours, they get benefits. So they want the monitors to actually have access to the benefits. So they want to put as many routes as possible. Monitors are able to jump off and jump in, which makes it even harder, right? So monitor can ride from, like they can be picked up from here, for example, from the lot, and then ride with these students. For example, let's say that this student needed a monitor, right? So they ride with this student. The student is dropped at the school, and then the monitor can keep going, or the monitor can stay here and potentially wait for another bus that going to a different school, even though the bus is different. So they're allowed to do bus hopping, which makes it very, very hard. Okay, so that's high-level description of the problem. Decision variables. We're assigning routes to packages, basically. Objective function is to maximize those routes per package, to make the packages as large as possible such that the monitors get their benefits. At the same time, we also want to minimize the transfers, which means that we want to try to have the same monitor assigned to the same person as much as possible, which sometimes it's not. Sometimes it might be that a student can have a different monitor Monday, Wednesday, Friday, and Tuesday, Thursday, because the routes are different per day of the week as well. Main thing is cover all students. We need to make sure that all students get their needs, and then monitors need to come back to the same yard. You're assuming that either that's close to where they live, they'll have their car there, their public transportation is there, so they cannot come to a different yard. Whatever hopping they do, they need to come back. Okay, slightly harder problem. So we're talking about 10 million binary variables. This is the hardest problem I've dealt with across 10 years of working optimization problems for multinationals, okay? Huge, huge problem. Linear constraints, so thank God it's linear. Linear constraints, 2 million. After years of work, we were able to get it down to 41 minutes. There is a lot that we did to be able to get it to 45 minutes. When we just started with what I call a naive formulation is a correct formulation. Usually that's how I start my engagements, just, okay, let's formulate decision variable constraints, kind of the more intuitive way. That was just not solving after days, okay? So then there was a very, very cool reformulation that we did through networks. So through network analytics. We started using, just at the, oh, I don't have it here, but basically kind of started using the buses, the routes as nodes. It's a little bit counterintuitive, right? Because you imagine like, okay, the schools and the houses are nodes, but we started using the routes as nodes and seeing which route can connect to which route depending on the place. And we reformulated the problem, and then we used network flows for that. And then we had like 2 more solves. I mean, there's like 3 solves total. At this point, it kind of sets for about 40 minutes. Super hard, the hardest mathematical problem we've solved. In progress, we're still working on them. The year before COVID, so COVID, we didn't do anything, but we kept working actually on improving performance for this. But 2019, we generated the packages for them, and they used maybe about 20% of what we generated, and the rest was from theirs. This year, they had a big situation there for the routes. So they still have actually some routes that they're working, about 230 or something like that, that we're working with them. But this is still in progress, so I'll have to update you next time. We used it as support, as I told you, like for partial, but we're still working and we're still kind of hoping to improve it such that it can actually be part of their yearly, so they can use it every year to generate these packages. Okay. So this is a YouTube. There's a YouTube video that we can explain on that reformulation that we did as network flows. So if you're interested on kind of how we improve performance from like a straight milk to network flows, there's a video explaining that. Okay, so last thing how I want to close this is maybe to tell you a little bit about how could you potentially work on projects that are supporting nonprofits, projects that are for the social, for the greater good. Okay, where do you find these opportunities as a student or as a professional? Okay, the only organization that's actually kind of does or looks at OR for social good is a competition. This is an Informs competition, and we got we're actually having, we had 4 finalists for this year. They're going to be announced in Informs, in the annual Informs in a couple of weeks, something on those lines, November, I think. But the next submissions are 2022. So you guys, I really, really invite you to consider, there's a link there. If you are doing any type of implementation, it has to be an actual implementation, it cannot be research work. I mean, research work, okay, but it needs to be applied. So if there is anything that you're doing, I will definitely invite you guys to consider this, as well as I'm assuming that you're going to be remoting or whatever to the Informs conference. I invite you to look at the presentations of the students that were selected. I happened to be in the committee, and it was impressive. I mean, those students, you look at those projects, like, my goodness, they're amazing projects. So I really invite you guys to look at those sessions in the annual conference Informs. Okay, another one at the Informs. Breathe. Another organization at Informs is Pro-Bono Analytics. So this is where we are matchmaking, like kind of like dating, but we're matchmaking here where we have nonprofits reaching out to us saying, hey, I have this problem. We actually scope them. So one person in the committee, we get together with these organizations and then we say, okay, what is actually the problem? Let's time it. So we do a little bit of scoping. So it's not like completely random, we do a little bit of scoping. And then we have a list of volunteers. You have to sign up for the email distribution list. And then you will get those, like if we get a new project, we scope it, we kind of distribute that, like create a one spreadsheet that you can understand what the project is about. And then it sends out by email. We wait for applications, we review kind of the resumes, all the applications, and then we do the matching between volunteers and the project, okay? We in the committee, we actually don't do the projects, but we do kind of just follow up and just check in maybe once a month or along those lines. So we're mostly like the matchmaking organization there. I'm going to skip it. Kaboom, we already have volunteers. Actually, I kind of had it before, but we got volunteers for Kaboom. It's a super cool project. They're looking at disparity in playgrounds across the nation. So for little kids, for example, the playgrounds, and they have evidence that it makes sense depending on the socioeconomic indices of certain neighborhoods. They have less opportunities. The kids have less opportunities. So they were trying to build those indices as well as build visualizations to promote building more playgrounds in this type of neighborhoods. Okay, data science for social good. This is an organization that that also has a really cool kind of way of online. Actually, they have projects that you can apply to. So very similar. This is not Informs, but they're very similar. They have different projects that go and you can actually see them. The Pro-Bono Analytics projects you cannot see. We actually do through email, but you see the projects and you can kind of submit the resume. You also see the type of projects that are happening there. They also sometimes have competitions, like type of Kaggle, but focused on supporting nonprofits. So that can be fun, okay? Analytics for a Better World. This is Dr. Bertsima's organization. They started during COVID in March 2020 as a series of webinars. They will just kind of do webinars once a month, every 2 months. Now they actually also have projects. There's no way that you can kind of apply for those projects, but you can get information and look at the projects they're working on and so on. And they still have the webinars that is open to everybody, that if you're interested, you just have to enroll and you will get notifications that they have another webinar. And obviously, Dr. Bertsimas. Okay, and finally, DataKind. I told you that organization I started with. They often have projects, opportunities. If you sign up in their list, you also will see those opportunities. And they also have jobs, actually. I think several weeks ago, they actually had a data scientist position there. I'm not sure if they still have it, but that's not as common, but they're actually jobs that that are focused on kind of supporting organizations for the social good. Okay, this was a community request that I was asking. So we are kind of getting a gathering of all these operations research projects for social good. And I have tons, funny enough, I have tons for mixed integer programming. I have none for linear programming. And by the way, guys, out of my 10 years of experience implementing optimization in industry, 95% of my projects are MILs. Like we rarely see a linear programming formulation in reality. We try to stay away from the non-linear ones as well by linearizing them, but most of them are MIL. So if you guys see kind of any or aware of any linear programming implementation, so not a research project, but something that actually was applied for some organization that was an LP model, I would love for you guys to reach out because we're actually writing a book. We're getting a collection of those, and I have none for linear programming. Okay. Okay, and that's all I had. I know I kind of walked through 4 very large projects, and there's a lot of information there, but I'll be happy to answer any questions for you guys. I'll definitely share the slides so there's more information, and I'm going to stop talking now. Any questions? Yes, please.
Considering your cases was very amazing. My question is, as a data scientist, it's a nightmare when data gets leaked. What do you do for preventing data leaks and data privacy?
Oh, that's a great question. So to be honest, I think I probably, since I work for an organization that builds software for data science, for me, that is taken care of. Okay, so to be honest, there's nothing that I particularly do besides following SAS guidance. But in terms of SAS guidance, so we have all type of secure SFTP servers and so on to be able to receive the data from our customers. So definitely a very big concern, not something I deal with particularly because that is dealt for me. Yeah, but a big concern nowadays. So any other questions, guys? Okay, sure.
So as a graduate student, I just wanted to know what is your toolkit? Every data scientist has a toolkit, right? So how do you define your toolkit? How can we design our toolkit?
Yeah, well, programming languages for sure, right? I always recommend one open source and one proprietary. So if you have like Python and C++, or if you have like Python and SAS, or R and like Groby, but so kind of you have that experience that you can with confidence put on your resume. Those tools are important nowadays. I mean, machine learning is sexy. You have to put something of that. So if there is a way to kind of implement one of your projects, you know, some experience or kind of get a certification from Coursera or something along those lines. Honestly, many times, even if you're not planning to use it, you will be asked in an interview if you're familiar with it just because it's such a big deal. I think, what else? Particularly if you are looking for a job in industry, practical experience is key. Okay, so internships or projects, sometimes projects that you work with your professors, but where you actually had relationship with the organization that you're applying to, okay? So if you guys are looking for a job in industry, you definitely need to get out there. Just a research-based thesis is not going to get you there. So it needs to be applied, and that means relationship with whatever organization you're working with. That means data cleaning. That means all the real stuff that goes beyond kind of like a research implementation. That is for industry, which is what I can talk about. Mm-hmm.
Are there any opportunities for NCSC graduate students as in internships or who are in SAS?
Always, they're about to open them actually. So check out the SAS website, but I think either like maybe in 2-3 weeks, they're about to open all summer internships. And there's a lot, like just in Advanced Analytics, there's like 9 of them. And there's all across SAS, there's many internship opportunities. And honestly, most of the time at SAS, at least, is that if you get a summer internship, we actually want to keep you. You know, as much as if the person hoping, the student that is interested, hoping that is good fit for the group, but we want to keep you with us all the way to graduation and after. So it's kind of, for us, it's a long-term engagement most of the time. So when we interview for internship, for summer internships, it's an interview pretty much like for long-term. Of course, sometimes students decide not to stay, and that happens, but yeah, so definitely watch out, and they are going to be there. There's going to be many of them. Yeah, please. Yes, there is free trainings. Let me take a note so I can remember to send it to you, okay? Yes, there is through NC State, you actually have access to many free trainings. And there's websites that you don't even need like an NC State email that have a lot of free trainings as well as a free environment where you can practice SAS. Let me take a note. Free trainings. Okay. Yeah, I'll send it out. I'll send it out with the deck. Okay. Sure. Yes, please.
Question on the first project. So
Yep.
You said that you guys reduce the cost by 55%. Is that fixed location or the
15. So 15, I actually don't have the cost from her. They didn't have that calculation. What was the from 6? So it was less than the 50%, but the solution was recommending that 50%. Yeah. Mm-hmm. Yes, please.
Just like thank you because it's really informative and really interesting. I'm a graduate student, so my question would be that you say you love coding and solving models. What would you address as the highest, the most difficult challenge to convert the scenario or the problem into a model? I mean, what keeps you awake?
Yeah. Yeah, that's a great question. So I think I'm going to answer slightly differently because translating the business problem into the mathematical model is hard, but maybe that's like one of my favorite parts. Like it's so cool, you know, to be able to listen to business folks talking, have no idea about optimization, and you have this math written, you know, it's so cool. The main challenge is actually how do you get their buy-in? You know, so I guess it's less of a technical challenge, but you write the problem, you solve this problem, but then how do you actually get them to use it? Many times when we are approaching someone to help them with their optimization, with their decision making, they probably have been solving that problem for 20 years with Excel, without optimization in their own ways, and the organization or their business unit keeps working, right? So how do you convince them that your solution is better? Which optimization is actually not so hard because you can prove optimality. You can show them, hey, look, in these conditions, I will recommend this solution for you. And they can go make their calculations. Oh yeah, that's better. But honestly, the main challenge we've had across projects is user adoption, more than a technical challenge in terms of formulation. Like formulation itself, it's not hard. What's hard is a good formulation, right? Kind of how, because there's many ways to formulate the problem. How do you formulate it such that you solve it within a reasonable time? So that can be challenging, but that has never stopped the project for us, like from happening. User adoption has, like we have had projects that have just stopped, you know, because we were not able to get to the point to actually convince the users to use the solutions. So I think that is something that comes to mind. I hope I kind of answered your question. Sure. Any other question, guys? Okay. Well, thank you so much for having me. I love talking to you guys. I'm going to send the deck. I'm going to send the information on the trainings. Feel free to reach out. I mean, you can find me on LinkedIn. There's my email as well. So feel free to reach out. Best of luck to you guys. Best of luck, of course, who are going to go through that. Don't work full time, okay? Till you are ready to work full time. Okay?
On behalf of Informed Success, we would like to thank Natalia for giving us such a wonderful presentation.
And I got a gift.
We do have many more events for Informs for the next sessions. Please stay tuned to our YouTube channel and also our social media updates. The goodies and snacks will be served outside the fixed cooler wall. So you might want to go there and grab some. Also, thank you so much for coming. It was wonderful to have you with such a busy schedule. Thank you for coming, and you have a great day.
Thank you.
Thanks, guys. Okay. So can I say, so look, the presentation is here. Okay, so you can just send this presentation. Actually, Actually, I'll send it to you.
Yeah, that would be good.
I'll send it to you, yeah, because it's on the text. Okay, I'll send it to you. I'm also gonna send you a link with trainings that they were asking for.
Yes.
And then you guys can send us. Okay?
You gave some really good career advice. Questions.
Well, that's
That was
good.
great,
Awesome.
yes.
Awesome.
Because many master students here are taking opportunities to get into the sector, the professional sector, and that's the career advice was really helpful. So many students will mostly contact you after this.
Yeah, absolutely. Yes.
Thank you so much.
Absolutely. Thank you.
Natalia, so I'm actually an undergraduate student.
Oh, okay. Awesome. Which year are you in?
I'm a junior level.
Okay, then you should take my class next semester. Data analytics. They're gonna, I'm not sure actually, again, we're gonna coordinate, but yeah, if you're interested in the field, now you're interested in operations research. So I'm sure it's gonna be
So I would love to connect with you.
Absolutely. Yeah, so did you already take the 361?
I'm in that right now.
Yes, it's awesome. It's amazing.
I will.
Okay, well, all those projects are implementations of what you are covering there, so that's a fantastic class. That was like my favorite in undergrad as well. Awesome. Well, good for you to be involved in forums like that. That's fantastic.
Thank you. I would like to connect with any internships or shadowing.
Okay. Yeah, absolutely. Send me a note. You can connect on LinkedIn, and also there will be an email. So what's your name?
Daniel Richter.
Okay. Yeah, and if you're interested, check it out because that's a special topic. Now that's for seniors, so maybe it will be next year for you actually. So that is the data analytics topics for seniors. Okay. Awesome. Yeah, you too. Hey guys.
Hi, thank you so much for the lecture.
Sure.
It was really insightful, like how data analytics is for the good. So I am very interested about data analytics sustainability of processes, about or making carbon zero the entire supply chain, how it can be used to carbon zero. So I'm very interested in that. So I'm learning. I'm a first year now, a master's student. I've taken introduction to operation research right now. I'm learning linear programming and everything makes it really but I'm finding it difficult to go from the theoretical aspect to actually implementing it because I don't have that much of exposure to coding. So I feel that is where I am lacking. So how do you suggest that I can go from the mathematical theoretical parts towards the application in machine learning? Or like how do I get into it?
Honestly, practice is the best way in terms of kind of getting projects. So I will suggest talking to some of the professors in terms of their opportunity to support some sort of a project. In your classes, you also like I know your first year, but you will have opportunities to actually like implement. They will have projects during classes, so that will be the best way. Because I understand how kind of when you're just starting, like how do you make that connection? You will have to very problem coding, but regardless what type of technique you do, you will have to do some coding that is supported for implementation. But yes, I will recommend for projects. There's not kind of like. Since it's not like a cookie cutter, I guess it's not like a or something on the science stream, you just have to go ahead. And sometimes students actually are able to find data and start working on their own. So Kaggle side, besides the competition, has lots and lots of data there. That you can just kind of get data and try to build a model, like if you talk about machine learning, like try to build a basic regression model from that data. And then you kind of start seeing the challenges, yeah, and ask your professors if there's one.
Difficult it is to begin. I'm really interested in this field and I want to work in this. So how difficult it is as a beginner to get into this? As in, like, what are the skill sets that you guys look for when you hire a person for the first time?
So programming skills for sure, and I think what I mentioned, kind of like the machine learning, regardless, like if you do optimization or just visualization, the machine learning is relevant nowadays, kind of to add it, and practical experience. So that's where again those projects will help you.
I'm sorry, but I want to know like what kind of how the interview section would be like. What will be the negotiation? Would you give us like the particular data set or the snippet and ask us to work on it?
No, that at least SAS doesn't do that. I know Amazon does that. No, we don't do like a working interview. So there's first, go ahead. First, there is a recruiter, which is like a very high level recruiter, is an HR person that will talk to you and they will